Hello everyone, you're watching Ultimate Chemistry. In this video we'll discuss the second element of the periodic table. So let's start the video. Helium is a chemical element with the symbol H, E and atomic number 2. It is a colorless, odorless, tasteless, non-toxic, inert, monatomic gas, the first in the noble gas group in the periodic table. Its boiling point is the lowest among all the elements. Helium is named for the Greek titan of the Sun, Helios. The first evidence of helium was observed on August 18, 1868, as a bright yellow line with a wavelength of 587.49 nanometers in the spectrum of the chromosphere of the Sun. The line was detected by French astronomer Jules Janssen during a total solar eclipse in Guntur, India. Janssen is often jointly credited with detecting the element, along with Norman Lockyer. Janssen recorded the helium spectral line during the solar eclipse of 1868, while Lockyer observed it from Britain. Lockyer was the first to propose that the line was due to a new element. In 1903, large reserves of helium were found in natural gas fields in parts of the United States, which is by far the largest supplier of the gas today. Some authors dispute the placement of helium in the noble gas column, preferring to place it above beryllium with the alkaline earth metals. They do so on the grounds of helium's 1s2 electron configuration. Although it is rare on Earth, helium is the second most abundant element in the observable universe, constituting 23% of its baryonic mass. It is present about 12 times the mass of all the heavier elements combined. Its abundance is similar to this in both the Sun and in Jupiter. This is due to the very high nuclear binding energy of helium-4, with respect to the next three elements. After helium, the vast majority of helium was formed by Big Bang nucleosynthesis 1 to 3 minutes after the Big Bang. As such, measurements of its abundance contribute to cosmological models. In stars, it is formed by the nuclear fusion of hydrogen. In proton-proton chain reactions and the CNO cycle, part of stellar nucleosynthesis. There is no chemical way of manufacturing helium, and the supplies we have originated in the very slow radioactive alpha decay that occurs in rocks. It costs around 10,000 times more to extract helium from air than it does from rocks and natural gas reserves. In 2014, the U.S. Department of Interior estimated that there are 1,169 billion cubic feet of helium reserves left on Earth. That's enough for about 117 more years. This helium-4 binding energy also accounts for why it is a product of both nuclear fusion and radioactive decay. Most helium in the universe is helium-4, the vast majority of which was formed during the Big Bang. Large amounts of new helium are being created by nuclear fusion of hydrogen in stars. On Earth, it is relatively rare, 5.2 parts per million by volume in the atmosphere. Most terrestrial helium present today is created by the natural radioactive decay of heavy radioactive elements, thorium and uranium, although there are other examples, as the alpha particles emitted by such decays consist of helium-4 nuclei. This radiogenic helium is trapped with natural gas in concentrations as great as 7%. By volume, from which it is extracted commercially by a low-temperature separation process called fractional distillation. Reactivity. Helium has a valence of 0 and is chemically unreactive under all normal conditions. It is an electrical insulator unless ionized. As with the other noble gases, helium has metastable energy levels that allow it to remain ionized in an electrical discharge with a voltage below its ionization potential. Helium can form unstable compounds, known as oximers, with tungsten, iodine, fluorine, sulfur, and phosphorus when it is subjected to a glow discharge, to electron bombardment, or reduced to plasma by other means. Therefore can exist only in isolation, as it will protonate any molecule or counteranion it contacts. This technique has also produced the neutral molecule of helium, which has a large number of band systems. Calculations show that two new compounds containing a helium-oxygen bond could be stable. Neutral helium at standard conditions is non-toxic, plays no biological role and is found in trace amounts in human blood. The speed of sound in helium is nearly 3 times the speed of sound in air. Because the natural resonance frequency of a gas-filled cavity is proportional to the speed of sound in the gas, when helium is inhaled, a corresponding increase occurs in the resonant frequencies of the vocal tract, which is the amplifier of vocal sound. Hazards. Inhaling helium can be dangerous if done to excess, since helium is a simple asphyxiant and so displaces oxygen needed for normal respiration. Fatalities have been recorded, including a youth who suffocated in Vancouver in 2003 and 2 Adults who suffocated in South Florida in 2006. In 1998, an Australian girl from Victoria fell unconscious and temporarily turned blue after inhaling the entire contents of a party balloon. Inhaling helium directly from pressurized cylinders or even balloon filling valves is extremely dangerous, as high flow rate and pressure can result in barotrauma, fatally rupturing lung tissue. Death caused by helium is rare. Liquid helium is used in cryogenics, particularly in the cooling of superconducting magnets, with the main commercial application being in MRI scanners. Helium's other industrial uses, as a pressurizing and purge gas, as a protective atmosphere, for arc welding, and in processes such as growing crystals to make silicon wafers, account for half of the gas produced. A well-known but minor use is as a lifting gas in balloons and airships. As with any gas whose density differs from that of air, inhaling a small volume of helium temporarily changes the timbre and quality of the human voice. Helium gas is used to inflate blimps, scientific balloons and party balloons. It is used as an inert shield for arc welding, to pressurize the fuel tanks of liquid-fueled rockets, and in supersonic wind tunnels. The space industry uses it in sensitive satellite equipment and spacecraft, and NASA